What's today? I think today's the 17th. It's a Wednesday. I got a physics test in 2 days, so I'll study physics. Hopefully it goes well. Let's get some music. What a great song. It's fantastic. Here's my patient, Janice. Symptoms. When falling asleep, feels a strong force on chest and throat, preventing her from breathing. Also has slight twitching in leg during episode. Potential cause. Could be sleep apnea, could be asthma, could be reflex, or could be epilepsy. What you have? I'm running with epilepsy. How are midterms looking, Mr. Corner? Okay, so midterms. My classes. I'm losing interest, but I'm doing okay. I think I have an 87% average right now. I'm only waiting on my Bachelor of Science in Psychology from U Ottawa. So doing pretty good, I think. How are your midterms, Dylan? Yeah. All right. What's up? Which program at Ottawa would you like more? I'm more interested in the Bachelor of Science. I don't exactly know what I'll learn in the Bachelor of Arts, but like psychology as a social science, I'm not really interested in. I'm trying to get into like neuroscience. Kind of lost interest in accounting, but it might just be because online classes suck. Oh, interesting. Damn, that'd be crazy. Done with accounting. Hello, Sam. How are you? My carbon monoxide alarm was beeping. I don't know if that's bad. I unplugged it. I think, well, pretty sure the battery died. That's why it was beeping. But there could be carbon monoxide. I doubt it though. What do I need? Not this. What's the homework? What's the review? Okay. Gotta love physics. You getting on later? Also, rip refusing. Wasn't planning on it, so I won't get on. I'll tell you when I'll get on though. Friday. Might be a short live. It might be. Hopefully not. I do feel a bit lightheaded. I'm going to watch some basketball, peace. Goodbye. Have fun. Won't leave until you say bye. Goodbye. I love you. Have fun. Okay. Let's here. Well, I got about. It looks like. Let's see. I got like 78 questions I can do, so that'll be fun to do. I'm gonna get blank paper. So if I know one thing, doing math is way easier when you have blank paper. Zero viewers. Very nice. Alright, so I've done no homework for this unit. Well, actually, I did a little bit. So that's a bit concerning. But, sure, I can figure it out. Let's go for an hour. See how it goes. Okay. Oh, that's right. Alright, I can do those. Okay, so we'll start. Come on, that's where we'll start. Determine the magnitude of the centripetal acceleration in each scenario. A penny is 13 centimeters. That's a radius. That's our diameter. So our radius would be 6.5. So radius equals 6.5 centimeters. Record playing on a 33.5 RPM. Now, what does RPM give us? Rotations per minute. What is that composed of? Where's my RPM? Would that be frequency? Frequency might be an RPM. Maybe it's frequency. Could it be frequency? If that's the case, it's 1 over t. T's the period. Period is, I don't know. What's the period? Should tell me somewhere. Period. The time required for a rotating, revolving, or vibrating object to complete one cycle. Frequency. The number of rotations, revolutions, or vibrations of an object per unit of time. The inverse of period. Okay. What do I need to work this? So, AC. We have an R. We need a T, or I need an F. The only way to get that is to isolate for F or T. But I don't have, no, I can't do that. Unless RPM is either F or T. Which in that case, I might have all the pieces to the puzzle that I need. So let's enter in a formula and just pray. Hopefully it works. I'm not sure if I should put that in meters. Meters a second. That's what acceleration is calculated in. It should be converted. What's the conversion? Centimeters? 100? 0.065? What is 0.65? Where's the calculator? Here's calc. Divided by 100. 0.065 meters. Okay. 0.065 meters over 33.5 RPM. Okay, 0.065. So if you do that first, we get that and divide that by 33.5, and we get a terminal acceleration of this, which seems awfully low. So let's try a different way. AC equals 4 boom squared. What's RF squared? Yep. So 4 33.5 squared is 122.25. That's a lot higher. Maybe it's too high. Okay, I need a... This is like a bookmark I can use. I gotta find the answers. Page 140. What happened to these pages? What have I done? When and where did I do this? Can I be sure it was me? 663. I've definitely never seen this page before. So it wasn't me. It definitely was me. Okay, 148. 140, there it is. 22. 22. No, I'm 21. 21. A is 1.6. Well, I'm off. I'm in the vicinity. 6, 1.6. Okay, so RPM must mean something else. Could this be 0.029? So my calculation. 3.3 forward 0.029. No, that's wrong. 3.1 forward 0.065 divided by 0.029. That's too big. It's way too big. What if I multiply by it? Two point one times 10 to it's still a little too big. Let's figure out what RPM is. To calculate RPM, you multiply the frequency in hertz by 60. Okay. let's do RPM formula, I guess. Let's see this word. RPM equals frequency, I don't know, times 60. So RPM should be 33.5 divided by 60. And that should give us frequency. 30.5 divided by 60, and that gives us 0.55 equals F. Let's run a calculation. 4.6, still too high. I'll try this one. 1.4, much closer. Much closer. Velocity. This gives me F. If I need T, T is a different story. I wouldn't really need T. I think so. 1.81. Try that. 1.416. Closer. I'll try this one. Too high now. Maybe I should use pi. Where's my pi? Pi squared equals that. That's 4. Closer, but not exactly. What am I missing? A penny is 13 centimeters from the center. Oh. Penny is not what I envisioned it would be a penny. Penny vinyl. What is a penny in a vinyl? I really don't know. But this is giving us a radius, not a diameter. I was wrong. This would be 13 centimeters, which would equal 0.013. No, it would be 0.13 meters, I believe. Okay, so let's change our calculation and see how we're doing. Let's use pi squared, that's 4 times 15 by 36.5. 1 is, okay, so that's too low. We'll try it again with different things. 0.113. That's too high. I'll try this formula. That's too low. Okay, so we have it, yes. Radius is good. 33.5 RPM. RPM is frequency times 60th a minute. RPM, so therefore RPM is divided by 60. 0.55. It's far too low. Squared. Alright, got it figured out. Good. So we're using this, we're using frequency. I'm gonna write that down. I don't really know that's a formula, but I'm gonna write it down because it seems to make sense. Boom. Must be a formula somewhere. We must have learned about it. Okay, so that's what that equals. 0.13 meters, and the frequency was 0.55 hertz squared. So give us 1.6 or 1.55. Who cares? 1.6 squared. Boom. Solid. B. The rodeo performer is twirling his lasso with uniform circular motion. One complete revolution takes 1.2 seconds. Time equals 1.2 seconds. The distance from the end of the rope to the center of the circle is 4.3 meters. Our radius is 4.3 meters. Acceleration should be simple. It should simply be 4. Nope. Yep. Maybe not. Should simply be wave velocity. I can't get velocity. I do have time. What is a formula I could use? Velocity. Speed. Velocity. Speed is distance over time. B equals distance over time. B equals 4.3 divided by 1.2. V equals 3.6 meters a second. Now, this can be V squared, so acceleration equals V squared over R. V squared is 3.6 squared over 4.3. 3.6 times 3.6 divided by 4.3 gives gives us 30.01, which I feel like is too low. Because I feel like I saw the answer, and the answer was very big. Very, very big. Okay. What am I missing here? There we go. 20b, 1.2 times 10 to the power of 2. That's a really big acceleration. 120 meters, meters a second. How did they come up with that? What did I do wrong? The distance from the end of the rope to the center of the circle is 4.3 meters. These 3, it seems awfully low. What am I missing here? The distance. No. Touring allows 1 complete revolution of the rope takes 1.2 seconds. I have 1.2 seconds. 1.2 seconds. It's awful. This should be fine. The distance from the end of the rope to the center circle is 4.3 meters. Frequency. There must be a bigger number. No mass. I know. Time required for rotating a roller. Okay, 1 complete revolution of the rope takes 1.2 seconds. The period, T, is 1.2 seconds. T equals that. If I have T, I have another formula to use. Let's try that. 4 times pi squared r over T squared. T was squared? Oh, I didn't square before. Yeah, that's why I got the wrong answer before. Okay. 4 pi squared r is 4.3. T is 1.2 squared. Should be a significantly bigger number. Much bigger. 169.6 divided by 1.44. Hopefully this is right. 169.6 divided by 1.44 equals 117.77. I believe the answer was 1. What was it? 2? I hope it was 2. So I have 1.17, which I could basically round up. That's why I say 120 times 10 to the 2 meters a second squared. Should be fine. I think that's the correct answer. If it's not, that's too bad. Gotta look closely at the questions. Little wordings. The electron is traveling around a around a nucleus at 2.18 times 10 to the 6 meters a second. Okay, that's a speed, not acceleration. The diameter of the electron's orbit is 1.06 times 10 to the negative 10 meters. Okay, that's diameter. So you tell me I have to divide this by 2. This disgustingly large number. That's awesome. Okay. That doesn't. I can't even put it in my calculator. That's how big it is. All right, I'm not doing that question. I'm gonna do it. There's no point. I'm gonna do it. All right, 22. You're operating a remote-controlled car on a circular path in an open field. The car is undergoing centripetal acceleration of 33.8 meters a second. So AC equals 33.8 meters a second squared. The radius of the car's path is 125 meters. 125 meters. Calculate the speed. Calculate the car's speed. We want speed. We want velocity. We want velocity. Okay, well, maybe we can use a simple acceleration formula. No, we don't have, well, we have R. We have to account for R. AC equals V squared over R. Now, we arrange this, we're going to have square root AC times R. That should give us V. Let's see how this goes. So 33.8. Frank Sinatra's playing. I appreciate this song. I sing it when I take showers. Times 12, 5, boom. 65 equals V. 65 meters a second equals V. Is that correct? 22, 65. Okay, good. That's correct. 23. Wind Seeker, a 30-story swing ride at Canada's Wonderland, ascends 91.7 meters. Ascends, okay. Spreads its metal arm and swings riders up to speeds, velocity 50 kilometers an hour. Calculate the ride's centripetal acceleration when the ride's operating at maximum speed and at full swing with a diameter of 33.5. So D, I think it's lowercase, D equals 33.5. I want that divided by 2. Divided by 2 would be, what would that be, like 16? Yeah, it's like 16.5. Is it 2, 5, 16? 16.525 times 2. Oh, so close. So close. It would be really cool if I got that. Off by a hair. 16.75. And my number's backwards. Okay, that's the radius. I'm looking for centripetal acceleration. So we have a velocity. We have a radius. Well, that tells me I have everything I need to solve. But there are other numbers here, which I don't know if they actually matter. Now, velocity is in km an hour, so I think I have to divide that by 3.16, and that gives me 15. So therefore, we have 15.8 divided by 16.75. Okay, so 14.9 meters a second squared. That's my answer. Is that correct? What was this? 23. It's very close. But it's not close enough. Why did I make a mistake? Why did I make a mistake? What have I not accounted for? Very short window, right? It says 9.17 meters. Spreads its wing. And swing speeds up to 50. Okay, so 50 is the max speed. I've done something wrong, I think. Seems way too fast. I'm gonna run with it though. I'm gonna give it a shot. Nah, that'd be way too big. 158. way too big, way too big. I'm not talking about addition, did we? What am I missing? Have I things wrong? Divide by 3.16. Okay, so this is completely right. 15 divided by 3.16 is 15.8. That's right. Did I square it? I did square it. I'm still wrong. 33.5 is the diameter. 16.75 is the radius. Use diameter. No question counts for that. So what did I do? Seems like a reach. If I figure out the distance traveled in the circle, the total circle, not diameter, distance around, and I divide that, and then I use that at speed, and I can find the acceleration, or I can find the time. With the time, I can use v2 minus v1 divided by time and get an acceleration. That seems way too complicated. It might work, but it doesn't seem necessary. I can't recall doing a question like that. What's the way to calculate? Okay, so we need circumference, maybe. Well, we'll run with it. It seems highly theoretical, but I'm going to try it. We know R. That's 2 times pi. 16.75. This doesn't... seems like too much of a stretch. 105.19 meters, I guess, or sure, we'll do meters. I think this is in meters. Are you in meters? What are you in? You're in meters, okay, good. Okay, we'll do that. We'll say that's our circumference. With circumference, maybe we can say that we can also substitute in this as a distance. So now we can do v equals distance over time. Well, distance, now we want time, so it would be v times, what did divide? Yeah, I'll go over here. So let's do divided equals time. 105.19 divided by 13.8. So we get 7.6 seconds equals our time. Okay, with time, now should simply be a speed, which is 13.8 divided by 7.6. That's too low, way too low. 13.8 minus B0, the max speed. It's still the same answer. So that can't be right. So that's not the right solution. It was a cool one. It wasn't right. Okay. 11.5 meters a second. 1.5 meters a second, and we're given the velocity and radius. Makes me think that this can be calculated, but I'm missing a number. Is it the ascends 91.7 meters? Spreads its metal arm with swimmers and riders at speeds up to 50 kilometers an hour. We do 15. And 14.9. It's just too high. This seems to be lower. Could I find T or P? I mean, almost given to me. That's a weird question. What if I leave it in that? That's really close. Did I do this correct? 3.6. What have I divided by? Oh dear. That's a mistake. I did 3.16. Like a fool. Okay. How could I be so stupid? Good thing I caught it. So actually our speed is 13.8 meters squared. Which should give us the correct answer now. 13.8 times 13.8 divided by 16.75, which gives me 11.4 meters a second squared. The answer was, or is, 11.5. I'll take it. It's close enough. No one's probably going to die. Good enough. 24. It's raining outside. It sounds awesome. I'm going to open my window. I love the rain. Oh, nice and wet. Just how I like it. That's nice. I don't know why. I love the rain. It's great. Everything's better when it's dark and gloomy. 24. The track near the top of your favorite roller coaster is looped with a diameter of 20 meters and a radius of 10. When you are at the top, you feel as if you weigh 1/3 of your true weight. How fast the roller coaster is moving. So, I don't know how much I weigh, but I know gravity. 1/3 of my true true weight. 1/3 of my true weight. 1/3 of my true weight. 1/3 of my true weight. I'm going to take a wild guess here and say my mass is equal to 3.3. Something, I don't know. With mass, and I want speed. I want speed. I want speed and velocity. We don't have that. Unless I'm using these equations. What would I be using? What has mass in it? Slope has mass. No, slope is n. What a tricky little question. Have to be 3.3. If I use gravity, maybe that's a stretch, but I'm gonna try it. So AC equals B squared over R. 33.3 times 10. Square root equals V. 3.3 times 10. 5.7 meters a second squared equals V. Doesn't. That'd be nice if it was the answer. This is 24. 8.1. Close. Close but no cigar. What am I missing here? What are we missing? When you're at the top, you feel as if you weigh 1/3 of your true weight. Well, we can assume normal weight would cancel out, so we would have a net force of blah, 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 blah. F equals NA, force equals NA, and acceleration. We don't have acceleration, but we could get a force more than that. Okay. mg, fg equals mg, fg equals mg, mg. Acceleration could be 9.8. 9.8. Oh wow, it's getting loud. 9.8. We don't have force though. We have no idea what force is. Hopefully my live stream doesn't end. That would suck. It's for you guys, not me. One third of your gravity. 1/3 of your weight. 1/3. 0.33. It's 9.8. 6.6. blows up. What does that mean? What a trick question. Where's the gravity? Actually, 9.8. 9.8. 9.8 equals mg. Maybe I can isolate g equals mg. It ain't divided by. Which really means my thing is that 0.33. Too low. It's really, really, really raining out there. This is awesome. I'm a big fan of the rain. A huge fan of it. It's very possible I'm missing a key component. I wouldn't know what it is though, because I didn't do any homework. And I also didn't. Well, I paid attention to a degree. What did we learn in this unit? Four things. So what else? Four things. Oh wow! Somebody's angry. It's not me. Okay, so this is wrong, which is awesome. But I don't know the right answer. How could I be so stumped? Could it just be like C? What's the solution, guys? Someone give me an answer. Nobody's here. I look like a madman. It's okay. I appreciate that quality of myself. Although I do understand this question. 8.1 per second. I can make it way. Is that my issue? Better not be my issue. No, this has to. It's weird looking. 0.7, 0.7, 2. Well, 8.1. One of these values needs to be increased by a little bit. These values need to be increased. Holy, it's really raining out there. I feel like in a shower. MV over R minus MG. Interesting. I found the exact same question. Exact same question. And the issue is, I have two different answers. Two different answers. 8 and 11. Maybe there's no true answer to this question. Where's the 4? Where'd you get the 4 from? R is 10. Where does 4 come from? Where the fuck do you get 4? Genuinely. Seems awfully dumb. 4. Where does the 4 come from? Genuinely, where is this 4 coming from? Also, could you get rid of gravity since gravity's on both sides? Cancel those out. You only have your R divided by 3 and divided by 1.8. There's definitely no 4. I don't know where they got the 4 value from. It's just not possible. The answer can't be right either, but I've already tried this answer. But we're divided by 3. 5.7. No, it's a 5.7. Yeah, 5.7. Maybe the actual answer is 5.7. The book's wrong. I don't know. I'll move on now. I spent too much time on this question. It's a silly question. 25. Locomotive engine has a mass of 3m. What's m? 3m. Pulling an empty cargo of mass m and making a turn on a rack, assuming that the engine and cargo are moving at the same speed. Compare the centripetal forces acting on each. Explain your answer. Centripetal forces. I should check that out. See if there's like equations or something maybe. I have that equation. But I don't have that equation. Fc equals mv squared over 2. Okay, well, that's an equation. I don't have that. Fc equal m times, okay, so Fc. Alright, I'm gonna shoot them there. I should write them down a bit. Okay, so there's 2 new equations to add to my arsenal. I wonder. I'm gonna redo this question. The previous one. I have a new idea. That I had new equations. Oh, it's been an hour. Actually, it was pretty good. An hour. Okay. Let's take a 5-minute break. I don't know what I'll do for 5 minutes. I'll do something. Okay, so I have a bio presentation and a bio test next week. I've studied nothing for the bio test, and I've done barely anything for the project, so I should probably do that this weekend. That's going to be the predominant amount of work. Functions assignment, nothing to worry about. It's not doing that with government yet. Okay, so right now I can feel this restricting on this. Wait a while. Hopefully all goes good. Alright, time to get back to work. Now on the clock. Okay. 9:36. No, stop there. Okay, new formula. New formula. We have FC equals MV squared over R. FC also equals MAC equals MV squared over R. Now, we're going to off a limb. We can cancel these out. We're going to say we have AC equals V squared over R. I heard that before, haven't I? We're going to say that AC is 9.8. R is 10. So once again, it's going to be 9.8 times 10 divided by, or not divided, square root of it. That's not going to equal V. It's not going to equal. Somehow, it's closer, but it's not correct. I'm missing component. But I really need that. I do. 2.3. Let's cancel nothing else. Let's bring it over. We have 0.33 squared times 9.8, which is times by 10. No, it's too low. I may never get this question then. It's truly stunning. Anyways, 25. So we have a mass, 3m. I don't know what unit of measure m is. Does it mean mass? Does it? What does it mean? I have no idea. Same speed, comparison to the forces acting on each. Is there an answer for this, or just like bullshit to give me a thing question? What is this? This is 25. Okay. F engine equals 3F cargo car. What the fuck does that mean? You give me a mass of 3m, as a matter of fact, which I don't know what that means. You want the centripetal forces, you want force, you want Fc equals acceleration times m. Well, I don't have a velocity or a speed, I don't have an r. But what you're telling me is that the engine would equal the cargo. Well, that makes sense, wouldn't it? They all have the same things, or the exact same speed. Cargo car doesn't have a known mass. I know what this question is asking. Therefore, it is a dumb question. It shall not be answered by me. You're riding on air gliders, a thrill ride at Galway Park, Calgary. The swing rides around in a circle while metal arms and move the cars up and down. What is the centripetal force experienced by a 90 kg mass rider swinging around at 20 meters a second, a radius of 16 meters? Okay, kg's got it. It's got to go in. No, kg's fine. Kg's probably fine. We don't usually use pounds. It's probably fine. Alright, what's the centripetal force? Well, I have a weight. I need to know mass. Gravity would probably be the fact. So let's say we have 882 newtons of, oh, it's Fg, isn't it? We'll just stick with 90 for now and see how it goes. Well, we have Fc, we could do equals mv squared over r. of all the pieces. If this works, I'll be a very happy person. So this one takes 90 divided by 116. FC is 0.250. And what the unit measure is it joules? It's kilojoules? What's the answer? 26. It's 2 times 10. It's newtons. 2 times 10 to the 3. So 2 times 10 to the 3, I believe, is 10 to the 2,000. Which it is, which means I'm correct. Boom. Awesome. That was B. That was A. Let's do B. Let's B. Look at the force and the rides I'm close to a radius of 10. Okay. So now the radius equals 10 meters. So, assuming the math's all the same, which it very well might not be. If radius goes down, that's to keep. Okay. Well, let's give it a shot. Let's see how it goes. 90 times 20 over 16. 20 times 20 times 90 divided by, that's 16. What am I doing? It's 10. No, it's 10. 360 newtons. It's a bit quicker. It makes sense. It's a less of a English route. That makes sense, right? That makes sense. B. It's 4,000. Are we rounding up? If we're rounding up, then I'm correct. I might do super rounding up. I'm off by 400 here, but I could round. Could round. Try C. C gives me the right answer. The math is probably correct. Five times 5 times 90. 10, 225. It's in twos. It is a 2, but was it 2 or was it 3? 2. Okay. I'm gonna assume you're supposed to round up. Okay, so 2 times 10, 2 to 2. Alright, cool. Easy question. 27. A discus thrower at a track. He hurls a 2 kg discus. If you exert a horizontal force, horizontal, okay, FX, yes, force of 280 newtons. As she spins, she rotates the disc with her arm. Sure, she rotates the radius of 1 meter. How fast will the discus travel? What speed? So we have a force. Do we have a centripetal force? Maybe. Maybe that's what that means. I don't know. We have an M. We have R. We have a V. So I'm going to run at the numbers. 280 equals 2 times V squared over 1. Everything comes over, so we have 280 times 1 over 2 square rooted. 280 divided by 2 square rooted equals 11. So we have 11.8 meters a second equals V. Is it easy as that? 27. 12. Yep, that's correct. Awesome. 12 meters a second. Good. I appreciate a nice, easy, so let's think this off. Okay, mass equals 2 kg, so a 2 kilogram jewelry box sitting on the edge of a rotating shelf in a mechanical display case. The radius of the rotating shelf is 50 meters, 0.50 meters, so R equals 0.50 meters. Calculate the centrifugal force when the shelf is rotating at 1 RPM. Well, we know what RPM formula is. It's frequency times 60. We need frequency, which means we're going to do 1 divided by 60. Wait a minute. 1 divided by 60. Interesting. Okay, so 0.16 is equals our F. That's our F. That's our F. Okay, so we want centripetal force. Centripetal force. Why do I need F? Why do I need F? Do I need F? I don't need F. What does RPM also tell me? I don't think it tells me shit. Okay. Zero point 0.16. This is F. Okay, now again, what kind of F? Get a period. If I can get a period, I can find acceleration. Oh, okay. We want force. I need the acceleration to get the force. What a disgusting question this is going to be. Let me get the one pick, because I think this is going to be a big question. 28. So, we have 2 kg as our mass. We have a radius of 0.50 meters. Let's switch that. We have a frequency of 0.16. That hurts, I guess. That's what we have. Now we need a C. We want a C, a frequency, so we can do 4 pi squared r frequency squared, which will equal 4 pi squared times 0.50 times 0.16 squared. So 3.14 times 3.14 times 4 times 0.50 times 0.16 times 0.16, and that gives us a big number of 0.50, which is frighteningly small. It's very, very small. That's what we got. So we have that. I have that. Now I got FC should equal M, which is 2 times 0.50. Now, this seems like it's going to be extremely low. We have a force of 1. Is that even possible? A force of 1? The question is, it's 28. Doesn't. What? That's what I said. 0.001. Mistake. What do I want exactly? I want a centripetal force. RPM is 1 divided by 6. 0.016. 0.016. What did I do before? What did I do? 0.016. If that's the case, I think this number is wrong. Okay, so 50. humongous number. That is a terribly wrong number again. I guess it's right. I guess the number is correct. Zero point 0.005. That's my guess. Okay, let's try this again and see how we do. This might be 0.01. Is that enough? 0.01 newtons. It's closer. Is it the correct answer? 0.011 newtons. I'm not going to get much closer than that. If I had the 4, actually, it might be 0.0454 times 2. 0.0. Yep. Okay. We'll take it. We did that question. What was that? It was A. That A. It was A. B. The shelf's frequency increases to 5 RPM. Okay, 5 RPM. So F is going to equal 5 divided by 60, 0.083. A fantastic number. So that's our F. Should be the same process as before, which is disgustingly tedious. 0.50 times 0.083 squared. So 4 times 4 times 0.50 times 0.083 times 0.083. Magnetic acceleration 0.35 newtons. FC should equal 2 times 0.135 newtons. FC should equal 2 times 0.135, 0.27 newtons. That was really quick. If I get it right, I'm cool. Oh, I got it right. I'm pretty cool. Okay. Decreases 0.50 RPM. Okay, decreases. So we have 0.50 divided by 60, which gives me a frighteningly big number. 0.0, say 3. Right? 1, 2, 3. Good enough. Okay, that's our, what is this? This is our F. Okay, so C equals 4 pi squared R. I know R. 0.50, 0.003. Okay, cool. You see equals 4 times 0.14 times 0.14 times 0.50 times 0.0083. I swear on that if it was 0.083. 0.01386 will say newtons, and now we do the same process. 2 times 0.0136 newtons. So equal 2 times 0.0136. We get 0.0272 newtons. It's pretty small, is that right? 0.0027. What did I do wrong? I did something wrong. 0.0083 times 0.0083 times 0.50 times 3.4 times 3.4 times 4. Okay. 0.013 times 2 gives me 0.0026, 0.0027. Okay. Just a little rounding difference there, but that's right. Great. 29 now. Oh, yeah, 29. That was a fairly straightforward question, a little tedious. Same thing. It's actually not too terrible. I assume it's going to get harder, but centripetal acceleration force is not too awful. I think predominantly the quiz will be tested on that. Or the test. I'm not sure, because we had a quiz that covered all of the first parts, so this one might focus more on this. Okay, right on. On a drop tower, Canada's one of the riders free fall, 23 stories at speeds close to 100 kilometers an hour. Wow, that's very, very fast. At some point during the ride, a person experiencing a force equivalent to 2G. G gravity? 2 times gravity? I'm going to assume that's what that means. I must say that a force, I guess in the y equals 2 times gravity, which is what, like 18 something, 18.16? No, I can't be right. 2.8 times 2. 19.6. That's what it is. 18.6. I was kind of right. Actually, I was pretty much right. And the ride seat is pushing up with a force of 1.1 times 10 to the 3 newtons. Okay, so maybe normal force. It looks like 1,000. Where is it? Yeah, 1.1 times 10 to the 3 is 1,000. What is the person's weight? Okay, so we want weight, I guess. And G. Mass. That's gravity. We have gravity. We don't have that per se. Fy would be the equivalent of Fg. Okay, so upward force. We're going down. Going down, which means they don't really look at the seat. That's what the seat's doing. So it's keeping them there. So they don't fall out of their seat. Let's do gravity. Okay, so you can say Fg1. I guess Fg in general is 19.6 meters a second square, perhaps. With a V, we have an acceleration, and we have a force. With the acceleration of force, we have a acceleration of 0. We have a force. Maybe I can do, but we don't have an A. We don't have an A. This one can't be explosive. There's nothing centrifugal about this. We're going down. This must be one of these equations. What do I need to solve the puzzle? I have a V. What does the V tell me? The V can give me nothing, so I don't have distance. We have forces. FGM. FGY equals MA. That's the acceleration. Say FGY equals MA. We know FGY is 19.6 mass. We have that acceleration. 19.6. Can be nothing but 1. High speed. Speed gives acceleration if we know the time. Do we know the time now? What's the answer to this question? This is number 29. Okay, I'm going to a different page. 29. Looking at 550 newtons. That's being applied. We're still falling. We're still falling. It's pushing up and falling. You can say that there's nothing. There's no force. Cancel no force out. There's no force of gravity and velocity. Could work with that. Could do that. So let's do 27.7. 27.8. Gives us that number. That's a big number. It's awfully big. It's awfully big. What was the unit they used? kg. It's newtons. Newtons. You can't tell me. Okay, this is not FG. This is gravity. It's not FG, it's gravity. But FG does equal mass times gravity. The issue is I don't know FG. I have an idea. If FG y or FG equals Fn, well, we know that this is broken down into MA. This is broken down. We know the answer to this is 1 that. Now it could be N equals this divided by 19.6. .6, 56.1. It's a bit much. For mass. 6.1. Okay, and we got 56.1. 6.1 times 9.8. It's 549. Round that Wait. Oh, I did it. Oh, shit. 5.5. Okay, I figured it out. Brilliant. Sick. Awesome. I'm going to take M times G. Cool, I figured it out. Awesome. So that was done. Page solved. Awesome. Okay. On this page. Great. Now we go to the hard stuff. Target B. Target B. 30. The blades of a blender. The blades of a blender of radius. The blades of a blender of radius. Okay, so 0.03 0m. Spinning at a rate of 60 RPM. What is the centripetal acceleration of a single point on the edge of one of the blades? I'll tell you exactly what that equals. So the figure of the frequency. Frequency is equal to 60 divided by 60. So it's 1. Interesting. 1. Well, it should be a simple question. We have a frequency, we have an R, we have a 4 pi squared RF squared, which is going to equal 4 pi squared times 0.030 times 1 to the square root. 4 times 3.1, 4 times 3.1, 4 times 0.030 times 1. And I get 1.18 as my acceleration, which is that fast for a blender? It's slow for a blender. 1.2. When it's fast for a blender, I guess. I don't know. Got it right. Alright, 31. The rock in figure 2 is moving in a uniform circular motion in a horizontal circle on a frictionless surface. The string is old and can only be exerted an action force of 25 newtons. Determine the minimum speed the rock can have without breaking the string. V. So we know that M equals 1.5 kg. R equals 0.50 meters. The string F tension can only go up to 25 newtons. So I want speed. I want the speed. What is it? That's mass. Well, let's say exactly what I have. I need an acceleration first. I can't get it. I don't know. I can't get it. Can't get it, can I? I don't know that. I'm gonna figure that out. Unless that's tension. That could be the that could be that. FC. Okay, let's try. FC equals mv squared over r. FC is 25 newtons, which equals m, which is 1.5, times v squared, which we don't know, which is 0.50. So overall, we have square root of 25 times 0.50 divided by 1.5, which is going to equal v. 25 times 0.5 divided by 1.5 square rooted incorrect. That is the correct answer. Awesome. Great. Okay, so Ft is equal to, I guess, Fc, which kind of makes sense, I guess, in a way. Uh-oh, he's me out. 32. The roller coaster is near the bottom of its track, as shown in figure 3. At this point, the normal force on the roller coaster is 3.5 times its weight. The speed of the roller coaster is 26 meters a second. Determine the radius of the track. Okay, so I need R. Now 3.5 times its weight. I don't know its weight. I'm going to assume I'm only going to use gravity, so I'm going to say it's 34. So I'm going to say the mass equals 34.30 newtons, I guess. I don't know. It's a cat. Yeah. At this point, the normal force is what I have. It's a cat. I don't know the radius. I don't know the acceleration either. Maybe I do know the acceleration. Acceleration could be that. This could be FG. FG is the acceleration. Let's shoot for the stars here. Equals V squared over R. So R equals V squared over C. And V, so is it 26 to 2 over 34.3. Is there an A? Oh, no, 30. Mr. Cat. Mr. Cat. We get a radius of 19 meters. Is that correct? Where are we looking? We're looking here. Look up here. I want to make sure. 31. I got 2.31. 28 meters for 32. Cheeky bugger. Okay, so there's something wrong. That's an issue. It's a big issue. What did I do wrong? It's gotta be something to do with the weight. And if it's a less of a number, it's gonna be higher there. Really, 9.8. Well, that's 68. We need to cancel out the mass. Mr. Cat, what's wrong? What's wrong? I think he wants to go outside. Oh, my legs. What are you doing? What are you doing? What are you doing? What are you doing? Go up. Come here. Come here. Come here for a hug. Come here for hugs. It's okay. It's okay. It's okay. There you go. It's okay. You're okay. You're a big baby. You want to do some math? Hey, are you scared of the math? Look, it's just mathematics. This is physics. Let's calculate your. Is it FG? Let's calculate the FG of you, Mr. Cat. Okay, so Mr. Cat, let's say you're like 9 kg, which might be, let's say you're 5 kg, Mr. Cat. Okay, so we have 5 kg. Right? Hey, don't bite. We have 5 kg. Gravity is acting upon you, right? So that's 5 kg times 9.8, because gravity is 9.8 meters per second squared. So your downward force is 49 newtons. But notice, Mr. Keller, how you're not going down, you're standing on my lap. That means that my body is exerting a force equal. So I'm pushing on you with 45 newtons, which is keeping you up. Hey, what are you doing? What are you doing? What are you doing? What are you doing? What are you doing, little guy? What are you doing, little guy? You can't leave. You can never escape. You're trapped here forever. You can never escape. Wow, wow, wow. You escape. Hey, let me kiss. There you go. Big baby. I guess he didn't like the physics. I don't blame him. It can be hard. It's 26 meters a second in the radius. What are you doing over there? What are you doing? What a jump. What a jump from the kitty. Oh, he's going up. He's disappeared. It's okay. I'm sure he's happy. I can't wait to end my stream. I'm so excited. My favorite part of streaming is when I leave the stream. I still got some minutes to go. Okay. So the radius is not that. Which means I did something wrong. How could I have done something wrong? How could I have possibly done something wrong? One of these forces isn't adding up. There must be a cancellation of weight. We know it's 3.5 times its weight. Well, this is the normal force, right? Fg. Let's try a little thing from before. G equals Fn. This might be a stretch. This might be a massive stretch. That'd be damn sure this worked. It seems. $13.8. Nah, that's too low. What's the sweet spot I'm looking for? What's wrong with the cat? I want to leave already. What? More Frank Sinatra piano? Gotta love it. we're looking for is the answer. Let's just clarify. 28. 28 meters. That's what I'm looking for. 28 meters. Too low. Divided by 24. Off by 10. Off by 10. How do I come up with that? That's how I did it. It's awfully bright. Can't really see the definition of my arm yet. One day. 18.6. 18.6. Too hard. That have to be a question I solve tomorrow. I'll make a note of it and say. Work on a different question. That's tough. That's tricky. Cardiovascular. Okay. Let's be seen. This is not really. Oh, they're gone. They disappeared. Where'd it go? Come back, little veins. I think it's the light. Makes them pop more. Yeah, they're coming back. Now they're gone. Maybe I just thought my hair blew in. Today, my friend's sister, we were talking about my hands. My hands are pretty dry, and we were saying it looked like radiation came. Or the friend said it looks like I have radiation on my hands, and then the girl said Chernobyl hands. Now I have referred to my hands as both radiation and Chernobyl hands. So I'm wondering if these are jokes that they're stealing from me, or they came up with these or they came up with these on the spot. Because there's a good chance the friend heard both of these jokes, but I'm not sure if the sister heard them. She might have. Makes me angry. How dare they steal my jokes? You're on the traction. Figure. No, fuck that. Radius is 11. Wheel rotates 3.5 times per minute. The wheel rotates 3.5 times per minute. So t equals 3.5. You want a what would it be? It would be simply 333. Now would it? Was this 33? No, it wouldn't. It would not be that. That's good. It would be too easy. I have to calculate something. Maybe I have to get We get V. Okay, so. I don't know. Need to first do 4 pi. Okay. $19.6. I didn't really do it all. But just simply used mass times AC, which is going to be, this will give me a big number. 1, 2, 2, 5. That's the force. What question is this? 2.9 times 10 to the 2. Take this and that's a big number. That's a very big number. Also, let's say this actually might be that's actually a very small number. What did you before? That's close. Oh. Okay, looks like it's time for bed. Oh, that's not too bad. You actually did a solid amount of work tonight. That was fun. I enjoyed that stream. Good session overall. Let's check our let's see if we got into any. See if we got into a new program. B, X, G, S, that, this, B, so V, G, that, U, not actually U, but let's just see if it worked. It worked. I got in here. Let's see. Under evaluation still. That's okay. There's something home for me. Admitted. Yay. Okay. Let's call it a night. Let's turn this bad boy off. Actually, I should probably pause my music first. That's fun. Bossa Nova Jazz. Good station. Really enjoyed it. Solid stream today. I'll pack this all up. There's been a mentality switch in my head. See, for a long time now, I've been trying to act not stupid. I've been trying to be not stupid. Be not stupid. That's funny. Anyways, that's a bad mentality to have, because the truth is, you're not stupid. So instead of trying to be not stupid, why don't you be smart? Act intelligent. Strive to be the best. That's what I'm putting. So that's the mentality. It's to be smart, to act smart. Not try not to be stupid. Not be not stupid. I have no idea what I'm saying. Complete waffle on my part, my apologies. Oh, I have a physics or a functions thing I should be doing. I'll have to give that a shot. Sometime tomorrow. Where's my to-do list? Should probably write it. I haven't wrote it in a while. Oh, it's bent out. That's great. Okay. What do I not need for you on here? You're marked. I have you. I have you. I have you. What are you? Biotest. 2034. Presentation. You're marked. You're accounted for. 16th. Test adjuster. Did that. 25th is accounted for. Okay. Oh shit. Oh wow, I'm so weak. Bigger soon. Alright. Tomorrow is April 18th. Now, I have physics is the priority. Physics study. That's what has to be done, and that's what will be done. Well, that'll be like an after school thing. Functions homework thing. And that's predominantly it, I think, for tomorrow. I'm not going to do any bio. I haven't really done any bio homework, but it might be maybe an issue. Because my test is coming up on next Tuesday, I guess. It's actually Monday, but I won't be there Monday. So, I gotta prepare for that. I also gotta do that presentation. I'm gonna write these on Friday. Okay, you know, I'm not gonna worry about it. I'm not gonna get ahead of myself yet. I know the tasks are on my board. That's tomorrow's work. So many eraser shavings, such a mess. Awesome. Oh, my physics book, of course. How could I forget that? And now we have this. I should probably do some reading tonight. I've been really getting into my sleep book recently and taking notes because it's pretty content heavy. It's not, I feel like Why We Sleep was not as heavy because I was able to retain a lot more of that. Whereas this time I feel like I actually have to take notes, and that's what I've been doing. This one's interesting. I really like it. I love how every chapter starts. It introduces patients, it introduces their symptoms, it gives a possible diagnosis, and then we progress through it progresses through by explaining what the diagnosis is and the causes of that, and then it will go through, talk more of the patient, discover more, I guess, history, and there may be a diagnosis, diagnostic, I don't know, diagnosis, or we'll stick with it and we'll figure it out. But it's pretty interesting. I like watching, or I like reading it, but it's content heavy, so it pays to take some notes. Anyways, let's I highlighted something. I didn't want to do that. 225 today. Oh wow, check that out. 225. 225. No way. That's crazy. 25 more days, we'll be at 250, and then only got like a month to go. Well, over a month, a little over a month to go. Anyways, thanks for joining the stream. If you did, I appreciate it. I'll see you tomorrow. Good night.